Hey, we have something here on the board. We have a radical problem that we are asked to simplify. We have the square root of 10 minus 2 over 4 minus 2 square roots of 10 minus 2 square roots of 8 plus 2 square roots of 20. Okay, so what I'm looking to do on this thing is some kind of factorization that's going to help me simplify this thing. The thing I like about these radical problems is actually it can be pretty hard to sometimes see what we need to factor or how to cancel it. Just because we're used to normally factoring with variables, factoring with radicals can be a little bit tricky. So what I want to do is kind of break this apart, and what I want to notice is kind of find some similarities, like this 2 square root of 20 looks like maybe it goes with this 2 square roots of 10, or I can do something with that. So let's just look at that separately. I'm going to write this down as 2 square root of 20 minus 2 square root of 10. Now clearly we can factor a 2 out, but what I want to do first is let's break down this square root of 20. I can write this as square root of 2 times square root of 10, and then we'll have this here. And now we have a 2 square root of 10 in common in both of these, so I can actually factor that out. So what I'm going to do is write this, we'll pull out the 2 square root of 10, and we'll write this but we'll still have this square root of 2, so we'll have square root of 2 minus 1 inside the parentheses. And then next I have this 4 and 2 square roots 8 to deal with, so let's see if I can do any simplification with that one. We'll bring this down here. But I think what I want to do, let's look at this square root of 8. Square root of 8 can be, we could write this as 4 times 2 in the radical, and then take the square root of 4 and write this as 2 square root of 2. So I can write this as 4 minus 2 times 2 square root of 2, but that's just the same thing as 4 minus 4 square root of 2. And then if I just factor a 4 out of this thing, this is going to give me 1 minus square root of 2. And then from here, I just noticed the similarity between this and this. This is just off by a minus sign. So if I actually pull a minus in front of this, I can flip this sign like this. So now these two are identical, just in a different order. So what I think I'm going to do next is let's take this term and let's take this term and put it back into the denominator, and then let's continue. Okay, now at this point we've rearranged our denominator, but we still have quite a bit going on. But again, what I noticed previously is, okay, we have this term in common. If we just factor that out, that's going to give me some more simplifications. We're going to have square root of 2 minus 1 here, and then we're going to have just 2 square root of 10 minus 4. Just notice we have a 2 in common here, so I'm going to factor out a 2, so that's going to go away, and this 4 is going to become a 2, and then we'll have our 2 out here. But doing that, now we have the same term here and here, and we get the cancellation that we're looking for, so we just can cancel this and cancel this. And so let me just rewrite this. So we're going to have a 1 in our numerator now, so I'm going to write this as a 1/2 out front, and we're going to have 1 over square root of 2 minus 1. And at this point, this is some pretty good simplification, like we could call this the answer, but typically we want to rationalize the denominators. What I'm going to do for this is multiply the numerator and denominator by square root of 2 plus 1, just multiplying by the conjugate, so we'll do it here as well. Then if we multiply this out, we're still going to have a 1/2 out front. We'll have a square root of 2 plus 1 upstairs. Then multiplying this together, square root of 2 times square root of 2 gives me 2. Then minus 1 times plus 1 is going to give me minus 1. But this thing reduces to 1 in the denominator, so we're left with our final solution, just 1/2 times square root of 2 plus 1. Okay, that's it. Just kind of a fun problem, simplifying it, not too bad. So we'll stop it there. Thanks everyone for watching today. Have a great day.